sorry, continuing here. So this is our triangle over here, irrational. Sorry, that's a solid I there. Rational numbers. All right. And so irrational numbers, we're going to write all in this corner here, cannot be expressed as a fraction of integers. So that means they are non-repeating and non-terminating decimals. Okay. So examples that I would like to have for irrationals. So I'm going to have a little arrow coming over here. You can't even see the arrow, sorry. I'm going to go ahead and give you some more difficult ones. I'll leave the easy ones for you guys to give me. So I'm going to go with maybe, how about the square root of 5? So the square root of 5, since it isn't a perfect square, we would have a non-terminating decimal that is equivalent. Or how about e? You guys remember e? That was Euler's constant. Okay. So I'm going to ask just for one example here. And I left the easiest one as an imaginary number for you. Okay. Let's go ahead and continue here. We had over here, we called these imaginary numbers. Sorry, just going to abbreviate that there. And we've given a couple of examples, such as 2i and 4i. So I'd like you to give me one more example here. And one other thing that we wrote over here for imaginary numbers is that if we had the square root of I times I, that's the same as, well, I squared. And I squared is actually going to give you the square root. So whenever we take the square root of something that's squared, it's actually just going to leave you with -1. So lastly, that leaves us with are all real numbers. Now, all real numbers, it's pretty much anything here. You could give me a counting number. So I could give you something like 52. Or I could give you a rational number like 1/2. Well, you heard that. That's the bell. So I'll leave you here. Just give me one more example of a real number. So that leaves you 2 counting numbers, 2 whole numbers, 2 integers, 2 rational, 1 irrational, 1 rational, and 1 imaginary. That's all I'm going to be checking on for tomorrow. Thanks.